G'day all, my name's Steve, and if you haven't guessed, I'm from Oz. Recently bought a Catamaran, Shambhala, and she's a Seawind 1000, around about 1995, 1996. Now there's two things on this vessel that had been decommissioned for some time. One of them was the Electrosan toilet unit, and the other was a Spectra Watermaker. So the Spectra Watermaker was the one I'm working on at the moment, and I wanted to make this video because I haven't been able to find anything really on the internet to deal with these older type Spectra Watermakers. The parts are very difficult to obtain, and it's a very difficult system to work on if you don't have previous knowledge. Now, I had absolutely no idea what to do with a Watermaker, so what I'm going to show you is what I have decided to do, and we'll work through it together and see what the outcome is. So this is what's known as a Clark pump. It's a hydraulic style or diaphragm pump for the Spectra Watermaker, and this is the thing I've been having all the trouble with. It has a high pressure inlet and outlet which basically receives the water back from the pressure vessel and essentially powers itself. So there's no electric motor or anything in this pump. Problem with this pump is it's very old, and it's very difficult to get parts for it. And you can see inside here there are cracks in the end cap, and it leaks from those cracks. I have been able to source one end cap for these older pumps, but unfortunately I still have leaks in the center casing here, and you can see I've tried to repair them with epoxy putty, but it still leaks. This J-tube was also leaking out of the connections here, so I've replaced this. It costed about $200. End caps are probably $150 each. If I wanted to replace this center block, it's going to cost me another $500 at least. And essentially this pump will need replacing to get it to work reliably. So what I plan to do is actually replace this pump with a 240 volt electric pressure washer to start with, just to see if I can get things up and running, and then we'll go from that point. No doubt you'll all be familiar with the gurney pressure washers. They've been around for a lot of years, and this particular model is the base model of the gurneys. It cost me 105 Australian dollars, so I'm not concerned that it's going to be a waste of money if I can't get this system up and running properly. I'm confident that I will. I'm just not confident that this motor is going to last all that long, but I have heard of other people using these particular cheaper pressure washers, and they've had no problems with them at all. This pressure washer will deliver 12 to 1600 psi, so it should push out enough for me to pressure up my pressure vessel. So what I've done is I have been to see my local hydraulic hose specialist, and he has taken my gurney hose and put a connection on the end of it for me so that it now fits into my pressure vessel, and the other end of the gurney hose will go on to the gurney. So this is just the normal gurney hose, 1/4 inch high pressure hose that comes with the gurney. A nice long hose so that I can put my pressure washer wherever I need to start with, to see whether this system's going to work. At the other end of my pressure vessel, I'll have a hose connected through the normal connection that this has on it, and then there will be a gauge and a tap. Now currently that's being sourced and made. I'll have that on a remote panel so that I can operate it outside of the cupboard where this system normally lives, and hopefully we'll get some results. So I'll be back to you once we've got it all set up and ready to run. So I had a little bit of problem with the audio on this video, so I'll just narrate it for you. This is just a proof of concept for the system. You can see now I've got the gauge and the tap. I've hooked the gurney up using Freshwater, and I have run that fresh water through a carbon filter to filter out the chlorine, because chlorine is not good for the membrane. So we want to run as pure water through there as we possibly can. I'm going to turn the gurney on. Now at this stage the pressure valve is completely open. We don't want to shock the system straight away. So we're going to just close that valve off slowly and build up the pressure inside the pressure vessel. I'm going to take it up to about 600 or 700 psi for the test. The pressure vessel itself is rated to 1000 psi, but we certainly don't want to take it up to its maximum capacity. So carefully closing off the valve just to bring the pressure up. Bear in mind that this is fresh water, so we don't need as much pressure to actually push the water through the membrane. It's not separating any or many solids at all. We're just going to get nice, fresh water out of there. Incidentally, I did test the water with a total dissolved solids meter, which I'm going to put in line in the system, and it purified this water exceptionally, even though it's fresh water. You can see there's quite a bit of pressure coming out of that now. I don't expect anywhere near that much on the actual boat once we start using salt water to pump it through. So the next step will be to install this in the boat, and to at least do a proof of concept inside the boat using salt water. So this looks like an absolute mess, but this is the Watermaker half installed in the boat. Under here we have all of the pumps situated and all the mechanics that were in here before. So there's a pump and filters, accumulator up here, a lot of different Y valves and things. I've installed the TDS meter in line so I can test everything out. So let's flash it up and see what happens. Okay, so we're all hooked up. Have the internal pump running. We have the gurney here hooked up, ready to go. Bypassed all the valves and basically just emptying water. You can hear it pumping here. See it pumping, I should say. So I'm going to start up the gurney. Have the valve set so that we can have water coming out of our sample tap. And now I'm going to just crank this up so we get some pressure in here. Take it up to about 700 psi. I'll get some more. Not yet, a little bit more pressure required. look to see what's happening down here. Got a little bit of pressure in here now. Oh, we've got a leak in our flow valve, that flow meter, so we need to fix that. And we have water. Let's go and have a look at the TDS meter. At the moment it's reading 800, we'll let it run for a little while. So EPA recommends 500 parts per million for minimum contamination level. There we go, we're getting down now, 400. So this membrane, as far as I know, has been in this boat for at least, well, probably 10 years. So far it's performing alright. TDS meter's measuring some fairly pure water now. Well under what the EPA recommends. So, somewhere here I have a glass. Here we go. Obviously this is all going to be hooked up to the proper discharge at some point in time. So there is our water. Have a little taste. Actually pretty good. Yep, very pure. Most happy to drink that. Flow meter has had it, but we seem to be getting a fair flow of water. I'm not going to send any through to the tank yet. Let's check what our TDS meter has to say again. I like that it's got an auto off, that's handy. 358, so calibration for this particular TDS meter is about 342. So it's a dual inline one. It wasn't terribly expensive, I think around about the $50 Australian. We are calibrated at 342 parts per million, which is pretty good. And we're on 350, so performing quite well, I think. Cut off this. Now it makes the other pump work, so I should have backed this off first a little bit. Cool. Now I guess I'll just install it and fix the leak in the flow meter. Apart from that, very happy.